100, number 16. Here is the figure that you're working with. We're working out the relationships when you have triangles that are made by parallel lines. Now, if these lines are not parallel, you can't do any of these relationships because all of these triangles are similar because they have angle-angle similarity. They have all of these corresponding angles in common, and so by angle-angle you can prove that this is a similar triangle to this one, and so forth. We can also use the side splitter theorem that I taught you about, which is a triangle proportionality, which also tells us that the segments that are across from each other are proportional in the same way as other segments, so you can relate the segments to each other. Now, this figure is labeled kind of backwards because we have A out here, which is very hard to figure out without first going over here and working out F. So you want to look at it, get a strategy. The easier ones to find are going to be starting down here where you have fewer things you don't know. Okay, now you need to relate. First, we're going to find F, and we're going to relate using the side splitter, which says if you have parallel lines, it splits the sides of a triangle into proportional segments. Okay, so to find F, we're going to say either 10 is to F as 15 is to 12, or you can say 10 is to 15 as F is to 12. So let's do 10 is to F. Okay, now you've got to make sure that you keep your sides lined up. We're doing the little triangle first, and we're doing 10 is to F. So we're doing the bottom segment to the top segment. You cannot turn around and then do it backwards and do the top to the bottom. So bottom to top, bottom to top. So 10 is to F as 15 is to 12. You could also say 10 is to 15 as F is to 12. 10 is to 15 as F is to 12. Either one would work. Now, if you remember your rules about proportions, you know that you can switch the means. Okay, if you interchange the means, you still have a true statement. But we need to have room to work. So we're going to erase the bottom one. All right, 10 times 12 is 120. And 15F, divide by 15. And using your calculator, 120 divided by 15 is 8. So F is equal to 8. Now it's very important for you to go ahead and put it in your figure then, because now you can use it. Okay, F is equal to 8. All right, now D, because D is a whole side of a triangle, and I want to talk to you about how that works. Notice that D is the whole side of the smaller triangle, and 12.5 is the whole side of this larger triangle. Now, we cannot be relating whole sides of triangles to parts of triangles. 12 is only from here to here. It's not the whole side of that triangle. So what you're going to have to do is think in terms of whole sides. So we would say D is to 12.5 as, we could say, using just the top segments, 8 is to the whole side, which is 20. Okay, as 8 is to 20. Okay, so you can work it out that way. Okay, or you could work it out by looking at the bottom segments. Just make sure you're not switching them. You have to keep consistent. We have small triangle, just the one side. The bottom side, I would think of it as kind of like the base. D is to 12.5. Whole side is to whole side, as whole side is to whole side. Okay, now you can reduce this fraction before you begin to work the problem by dividing by 4, and you get 2 and 5. Okay, so you get 12.5 times 2 is 25, which is equal to D times 5, which is 5D. And then you divide both sides by 5, and you get D is equal to 5. So we're going to mark that as well, because we need to have that in there. Another way you can work this problem is to relate it to the bottom segments. You could say D is to 12.5, as 10 is to, you need the whole side here, 10 is to 25. Losing my marker here. Okay, now once again you can reduce this and you get 2 and 5, and then you get 5D is equal to 25. Dividing both sides by 5, we get D is equal to 5. Okay, so that's how you can find D. So we have 5 and 8 here. Now using the side splitter, remember this, I'm going to erase the things that I'm drawing on here. Using the side splitter, which says that if you have a segment going across a triangle at a line parallel to a third side, it splits the sides into proportionate parts. Okay, so if we're trying to find E, we can relate the parts of the triangles as long as they're just parts. So we have 12 is to 15. Okay, now notice this is like the left-hand side or the top part to the bottom part. You can't do bottom to top. You have to go top, bottom, top, bottom. So this is E right here, as E is to 5. And once again, you can reduce this by dividing here by 3, and you get 4 fifths. Okay, that makes it a little bit easier for you to do multiplication. You don't have to do that. If you didn't do it, you would get 5 times 12 is 60, and 15 times E is 15E. Dividing both sides by 15, you would get E is equal to 4. Working it this way, you get 4 times 5 is 20. 5 times E is 5E. Divide both sides by 5, and you get E equals 4. In any case, E is equal to 4, so we're going to mark that. Okay, so we found F, D, and E. Now let's find F, D, E. Let's go ahead and find C. Now C is a whole side. And then we've talked about this before. Because C is a whole side of this triangle, we have to relate it to a whole side. So we could say, let's make this easy. Let's skip here and skip this one in between because that's a decimal. And we'll just say 5 is to C. 5 is to C. So here we're doing the whole side of the smallest triangle to the whole side of a larger triangle. Now we're going to have to do our sides. As 8, okay, 5 goes with the small triangle, so 8 has to go with the small triangle. As 8 is to this whole side. 12 plus 8 is 20, plus 4 is 24. Now, as I said before, you can always reduce it before you begin cross-multiplying. And since this can reduce into 1/3, dividing by 8, we get 5 times 3 is 15, and C times 1 is C. So we get 15. Okay, so now we can work towards finding A and B. All right, to find B, the easiest way for us to find B is to relate the segments. So let's say 4 is to 5. 4 is to 5 as 12.5 is to B. Well, we can't reduce anything there, so we have 4B is equal to 5 times 12.5. 5 times 12.5 is 62.5. Divide both sides by 4, and we get B equals 15.625. And go ahead and carry that all the way out. All right, and the last side we need to find is A. Now, we're going to have to relate A to a whole side. But notice we've got, I forgot to mark it in here, we've got 15.625. Decimals are necessary in these problems because it's very difficult to actually draw a figure that won't have any decimals in it. Okay, so when we're doing this whole side here, it would be easier for us to use this side of the triangle to find it because this side has this really long decimal in it. So rather than adding all of that up, we'll just work on this side. We have 24 here. 24 plus 10 is 34, and 2.5 more is 36.5. So the whole side here is 36.5. So we have the whole side A, is to, let's go ahead and use the C side, that's fine, or we could use D. Let's do that one. A is to 5. We'll do that one because it's smaller numbers. Okay, A is to 5 as 36.5 is to 8. 36.5 being the whole side. Notice again, we have a whole side of the largest triangle to the whole side of the smallest triangle is related to the whole side of the largest triangle and the whole side of the smaller triangle. Okay, so we get 8A equals 5 times 36.5, which is 182.5. Then divide both sides by 8, and we get A is equal to 22.8125. Okay, and that's how to work number 16 on page 400.